Ever looked up at the sky and wondered what's protecting us from the sun's powerful rays? It's not just the atmosphere itself, but a special, invisible shield called the ozone layer. Today, we're diving deep into what this layer is, why it's so crucial for life on Earth, and the incredible story of how humanity came together to save it. So, what exactly is the ozone layer? Imagine our planet wrapped in a blanket of gases. This is our atmosphere. Way up high, between about 15 and 35 kilometers above the surface, in a region called the stratosphere, there's a higher concentration of a specific molecule, ozone. Now, you might be familiar with the oxygen we breathe, which is O2 to oxygen atoms bonded together. Ozone is a supercharged version of this, O3, with 3 oxygen atoms. This third atom makes it highly reactive and, funnily enough, a bit toxic to breathe in large amounts down here. But up there, it's a lifesaver. The ozone layer acts like Earth's sunglasses. The sun doesn't just send us light and heat. It also bombards us with different types of ultraviolet or UV radiation. We usually hear about UVA and UVB. UVA rays have longer wavelengths and can penetrate deep into our skin, causing aging. But the real villain is UVB. These shorter wavelength rays are much more energetic and dangerous. They are the primary cause of sunburn and can lead to serious skin issues. But there's an even more dangerous type, UVC. UVC radiation is the most energetic and destructive of the three. If it reached the Earth's surface, it would be devastating for most life forms. This is where our hero, the ozone layer, steps in. The magic happens through a continuous cycle. When UVC and most UVB rays from the sun hit the stratosphere, they strike ozone molecules. The energy from the UV radiation is powerful enough to break the O3 molecules apart, splitting them back into an O2 molecule and a single oxygen atom. But this single oxygen atom is very reactive and doesn't stay alone for long. It quickly finds another O2 molecule and recombines to form a new O3 molecule. This constant process of ozone being broken apart and reformed is called the ozone-oxygen cycle. It's a beautiful, natural chemical dance that absorbs about 98% of the sun's harmful UV radiation. By converting this dangerous energy into heat, the ozone layer not only protects us but also helps to shape the temperature structure of the stratosphere. It's an elegant and vital system that makes our planet habitable. Without it, life as we know it simply couldn't exist on land. So, for a long time, this protective layer did its job perfectly. But then, in the 20th century, we humans introduced some new chemicals into the atmosphere that threatened to unravel this delicate balance. In the 1970s, scientists began to raise concerns about a group of chemicals called chlorofluorocarbons, or CFCs. You might remember them from old aerosol spray cans, refrigerators, and air conditioning systems. They were considered wonder chemicals at the time, non-toxic, non-flammable, and incredibly stable. That stability, however, turned out to be a major problem. Because CFCs are so stable, they don't break down in the lower atmosphere. Instead, they slowly drift all the way up to the stratosphere. Once they get there, the intense UV radiation that the ozone layer is supposed to block finally breaks them apart. And when a CFC molecule breaks, it releases chlorine atoms. A single chlorine atom in the stratosphere is like a tiny Pac-Man on a mission to destroy ozone. Here's how it works. A chlorine atom steals an oxygen atom from an ozone molecule, turning O3 into O2 and creating a new molecule, chlorine monoxide. But it doesn't stop there. The chlorine monoxide then reacts with a free oxygen atom, which releases the chlorine atom to go off and destroy another ozone molecule. This is what makes it so destructive. A single chlorine atom can remain in the stratosphere for decades, destroying thousands upon thousands of ozone molecules before it's finally removed from the cycle. It's a catastrophic chain reaction. The real wake-up call came in 1985. A team of British scientists working in Antarctica made a shocking discovery. They found a massive, seasonal depletion of ozone over the South Pole, what came to be known as the ozone hole. This wasn't just a small dip. It was a huge area where ozone levels had dropped dramatically. Why over Antarctica? The extreme cold of the Antarctic winter creates unique conditions. Polar stratospheric clouds, made of ice and nitric acid, form in the intense cold. The surfaces of these ice crystals provide a perfect platform for chlorine chemistry to go into overdrive. When the sun returns in the spring, the UV light triggers the rapid destruction of ozone, creating the hole. The discovery of the ozone hole sent shockwaves through the scientific and political communities. The abstract threat of ozone depletion was now a tangible, frightening reality. The evidence was clear: our industrial activities were punching a hole in our planet's protective shield. Increased UV radiation would lead to a surge in skin cancer, cataracts, and harm to immune systems. It would also damage crops, disrupt marine ecosystems by killing plankton, and affect the entire food web. The world had to act, and it did, with remarkable speed and unity. This brings us to one of the greatest success stories of international environmental cooperation, the Montreal Protocol. Signed in 1987, the Montreal Protocol on Substances that Deplete the Ozone Layer is an international treaty designed to phase out the production and consumption of ozone-depleting substances, primarily CFCs. It was a landmark agreement. For the first time, nations around the world agreed to legally binding controls on chemicals that were damaging the global environment. What made the Montreal Protocol so effective? First, it was based on solid science. The link between CFCs and ozone depletion was well established. Second, it was flexible. It started with modest goals but was designed to be tightened as more scientific evidence became available. And it has been amended several times to accelerate the phase-out and add new chemicals to the list. Third, it provided financial assistance to developing countries through the Multilateral Fund. This helped them transition to ozone-friendly technologies, ensuring that the burden wasn't just on the industrialized nations that had caused most of the problem. This principle of common but differentiated responsibilities was key to getting everyone on board. The results have been nothing short of extraordinary. The production of CFCs has plummeted by over 99% since the treaty was enacted. Scientists are now observing the first signs of healing in the ozone layer. The ozone hole over Antarctica, while still appearing each year, has stabilized and is slowly beginning to shrink. Projections show that the ozone layer over the mid-latitudes could recover to 1980 levels by around 2050, and the Antarctic ozone hole could close by the 2060s. The Montreal Protocol is often hailed as the most successful environmental treaty in history. It shows that when science, policy, and industry work together, we can solve major global challenges. It prevented a global health catastrophe and also had a huge, positive side effect for climate change. Why? Because many ozone-depleting substances, like CFCs and their replacements, are also potent greenhouse gases, some of them thousands of times more powerful than carbon dioxide. By phasing them out, the Montreal Protocol has actually averted more warming than any other climate agreement to date. It's a double win for the planet. But the story isn't over. We still need to be vigilant. The replacements for CFCs, known as hydrochlorofluorobonds or HCFCs, were less damaging to the ozone layer but are still potent greenhouse gases. An amendment to the Montreal Protocol, the Kigali Amendment of 2016, is now working to phase down these HFCs as well, further protecting our climate. There are also occasional, worrying reports of rogue emissions of banned chemicals, which highlights the need for continued monitoring and enforcement. Our atmosphere is a complex system, and we must keep a close watch to ensure the recovery stays on track. The saga of the ozone layer is a powerful lesson. It teaches us about the interconnectedness of Earth's systems and how human actions can have profound, unintended consequences on a global scale. But more importantly, it offers a message of hope. It demonstrates our capacity to recognize a threat, listen to the science, and act collectively to protect our shared home. From the silent chemical dance in the stratosphere to the global political agreements on the ground, the story of the ozone layer is a testament to what we can achieve. It's a reminder that we are the guardians of this beautiful planet and that by working together, we can secure a healthier future for generations to come. Thank you so much for joining me on this journey into our atmosphere. If you found this explanation helpful, please give this video a thumbs up and subscribe for more deep dives into the science that shapes our world. Let us know in the comments what other environmental topics you'd like to see explained. Stay curious and see you in the next video.